So for those who I don't know in the room, I know many of you in the room, but for those of you that I don't know, I'm Nick McKeown, and I'm a professor here at Stanford. So welcome to Stanford. Welcome to our home here. Not every building on campus is as fancy as this one, but it's a beautiful setting to hold a workshop like this. So thank you very much for being here. There's a long day ahead of us, so I'm going to be very brief. I'm really just here to welcome, do a little bit of stage setting for the day. It's pretty incredible, the range of organizations that are represented here. I was just sort of scanning through the list of people who are here today from many different companies from all across the networking industry. Frankly, when we've had the first workshop a couple of years ago, most people were from academia. And that's partly why it was originally set up to be held on the campus here. Today, it's more than 80%, I think it's actually 90% of the people here are from industry, potential users, programmers, developers of P4. So it's really going through a transition, or has gone through a transition from being a new exploratory language to one for which people are now developing real applications. So it's really exciting to see. Just to set the stage a little bit, I assume that if you're here, you know something about what P4 is, otherwise you could be in the wrong place. As I hope you know by now, P4 is a declarative language, a way to specify what should happen in a programmable forwarding device. And not so much the how, we leave that to the compiler in order to be able to turn that into behaviors that run on a programmable device, but to give you a way to express and declare what behavior you want a forwarding device to have. One of the things that you will have seen if you've looked at P4 programs already, or you will discover during the day today, is it's very familiar. When the P4 language was first constructed, the goal was to make it easy for someone to read and understand, easy to extend and enhance, and easy to create new behaviors. And you'll see this in the language. There's really three parts to it. One is to describe the headers and the metadata that you use in processing, all very familiar. You'll recognize the examples today as L2 headers, L3 headers, things that we've all seen over many years. Match action tables, which are really the guts, the heart of where the processing takes place. What matches, what fields to match upon, and then what actions to take upon those fields. And then parsers for parsing headers, for deconstructing the headers that have been expressed. And then the control flow, what a packet experiences as it goes through a pipeline. It was described this way and declared this way to make it as independent of individual targets as we could possibly make. We didn't want it to be tied to a particular ASIC, to a particular FPGA, a particular MPU, a particular end target device. So the goal has always been target independence to the extent that was possible. And also to make it easy to learn. So I could stand here and talk for ages about examples that I have seen over the last year of people learning P4 for the first time and using it to program a variety of devices. One was somebody who had contacted one of the authors of P4 in the morning, said they'd just heard about P4, went off, downloaded some of the materials at lunchtime, and by the end of the day had checked in a new example for processing video in the forwarding plane or something. I can't quite remember what the example was. So there are a number of examples like this, and for me it was kind of exciting to see that people were now not thinking about the device, not thinking about the target, not thinking about the how. They were expressing a behavior that they'd wanted to see happen in their network for a long time, and now had a means to express it. So it gives you a way to describe forwarding behaviors for a variety of different applications. I've listed a few here. But the key here is that not only can you use it to declare the behavior that you want, I want to leave you with a thought of how P4 might become more widely used in the future. And that is as a way of specifying forwarding behaviors in an unambiguous way. Because once you have a strong language and a strongly typed language like P4, it gives you a way to describe behavior that others can then follow. Not only is it an executable specification, but it can give you an unambiguous way of describing a forwarding behavior in a standards document. And we've seen a couple of examples of this over the last year or two, where people who build and operate large networks, AT&T was the first, but others have done it too, where they took a behavior that they wanted to see in their network. They described it in unambiguous P4, and then they took that behavior and gave it to suppliers of equipment to them and said, this is the behavior that we want. We don't care whether you have a compiler. We don't care whether you have a particular programmable forwarding device. This is a specification of the behavior that we want. And by the way, when you give us that behavior, we're going to then test against it because we've got the unambiguous specification. And so we're not going to take buggy implementations. That will be the behavior that we want to deploy in our network. So it really changes the dynamic of how these behaviors get specified. And then you can publish it. You could put it as a section in an IETF spec or an RFC as an unambiguous representation of forwarding behavior. Because today, if you think about it, when we read RFCs, we're reading something which is in ambiguous English. And it's not surprising that we have to spend millions and millions of dollars on interoperability labs in order to check that those behaviors are correctly implemented. So it gives us a path through P4 and perhaps other declarative languages to be able to have a much cleaner, clearer, and less ambiguous way of specifying behaviors in networks, which is something I've hoped would happen for a long, long time. So we're very excited about that. One last thing I wanted to say before I hand over the floor to Vlad, and that is, you're going to see today that there is a change taking place from P4.14, the original version of the language, to P4.16. So over the last couple of years, there's a lot of experience being gained with P4. And of course, as that experience is learned, then you learn some of the shortcomings of the language. One of the really fantastic things about a language which is open, which is built around a community, is that the community as a whole can not only learn, but then improve upon that language. And so P4.16 is an improvement upon the original P4 language. By being an open community, we've been able to draw on and bring in some of the best people in the programming languages community. Nate Foster, who's sitting at the back, Mihai, who's at VMware, Cole Schlesinger, who was one of the original creators of the P4 language, and many others, who have helped continue to evolve and improve the language. So when the exercise was started to improve upon the language, and I'll tell you some of its characteristics in a moment, you have to think about that very carefully. Because there was a community of users already growing with the P4.14 language. And so there was a mantra that the group adopted, and that was borrowed from other efforts in programming languages. And that is to try and ensure that anybody who is using the language and writing in P4.16 should not dread or fear a future situation where they have to modify and port their language to a later version. So in P4.16 version 1.0, which was, in fact, I think it's released today or yesterday. It's just in the process of being released right now. The goal is to make sure that it's minimal of hassle in moving from P4.16 v1 to future versions of P4.16 over the next couple of years, because no doubt as an open source language, there will be minor tweaks as more is learned. So P4.16 aims to retain the strengths of P4.14, that declarative approach, and it has some enhancements. The first one, the biggest enhancement, is the separation of the target architecture from the language itself, from the way in which you describe the behavior. If you're familiar with P414, you'll know that P414 was targeted to a particular forwarding model. It was what we call the PISA-like model. And PISA is a particular pipeline approach. Now, this fits with most ASICs, but it doesn't fit with things like FPGAs, which have more freedom, NPUs, which are structured differently, or just regular CPUs. So now there's a means to express the architecture, which is the target architecture, and the language. And so the compiler takes in both so that the program that you write is correctly compiled to the architecture that you're using. It also allows specific capabilities of targets to be exploited. The language itself was beginning to grow a few barnacles around things like checksums, some special sort of special capabilities. And these don't really belong in the language. They belong in the description of the architecture. So now those are put into the description of the architecture. You'll see some examples of that today. And they're expressed as externs that allow you to express particular characteristics that an architecture has. P416 has a much improved static type definition that allows you to express the various types, headers, etc., that you have in your program in a much cleaner way. And so you can, and also less prone to ambiguity. There are some ambiguities in P414 that have now been eliminated. And allows you to create some higher level constructs that will hopefully lead to more code reuse. Because one of the great things about having a community, an ecosystem like P4 is the reuse of code that we write, that our colleagues write, and that people from across the industry create. And you'll see some examples in p4.org in the repository right now of programs that have been written by people in this room that have contributed to that community that we get to reuse in a variety of different situations. So today, the focus is going to be on learning how to use P4 with some examples for some specific architectures. And the whole of the morning session is going to be an overview and an introduction to P4 as a language. And that's going to be led by Vlad, who is over here. I'm going to hand over to him in a moment. Before I do so, I just wanted to say that a day like today takes a huge amount of organization, which was done by a number of people in the room, not me. I'm just here as the opening the event. And you'll meet many of them during the day. Vlad here, Robert sitting on the front here, Nate at the back, Nate Foster, people who you met on the front desk earlier, Chris, Chloe, Melody, who were helping, and Prem. Where is Prem? Raise your hand. Prem at the back here, who's done a huge amount to organize today. And so I'd like to thank everybody that's been involved in the organization. It's been a terrific amount of work. So thank you.